week 4 for GATE previous year question solution, and today the topic is surveying. Questions will discuss two previous year questions. First will be from tachometry, second from photogrammetry. Today's session will be focused more on the photogrammetry side. So it just to finish our quota, we'll have that one question from tachometry, a simple question, and we'll discuss a little bit detail in the photogrammetry. Okay, so let's start. So the first question, GATE 2014 set 2, question number 54. A tachometer was placed at a point P to estimate the horizontal distance between PQ and PR. The corresponding stadia intercept with the telescope kept horizontal are 0.32 meters and 0.21 meters respectively. The angle QPR is measured to be 61 degree 30 minutes and 30 seconds. If the stadia multiplication constant is 100 and stadia additional constant is 0.1 meter, the horizontal distance between QR is. So this question is basically, normal formula based question with simple, trigonometric formula, additional formula. So let's do this. So those of you who joined just now, in this we will be discussing tachometry and photogrammetry. Basically, our main focus for today will be photogrammetry, and this to finish our quota, we have the tachometry question. Okay. So what is this? How do we get the distance from the stadia intercept of a tachometer and then stadia multiplication constant and stadia addition constant? Fairly simple. If you have done, surveying in your bachelor's, you will remember this. You remember some formula like D is equal to Ks plus C, where S was your stadia intercept, your K was your multiplication constant, and C was your addition constant. So we even did some experiments to identify whether the tachometer we have purchased, they have actually the multiplication constant and the stadia addition constant to the desired value or not. So people used to do some manipulation and get K equal to 100 and C equal to 0.1 or 100 centimeter. Those were some fun memories, but yeah, these things actually help us remember these kind of formulas in the long run. Okay, so you can using this stadia intercept and your multiplication constant and addition constant, you can actually identify the distance of an object, how far the object is from the point where you are looking at it. So we have the stadia intercept for PQ, and we have the stadia intercept for PR, and we have the angle, that is QPR, that is 60 degree 30 minutes and 30 seconds. So you should know that in 1 degree we have 60 60 minutes, and in 1 minute we have 60 seconds. So if you were to simplify this, it will be 0.5 minutes, and if you were to simplify this, it will be 0.5 degrees. So we have some rough estimate. We don't need to be very precise. Let's just say that is 61.5 degree, right? And then this will be 30 divided by 60, something like that it will be, which will be very less value when it comes to degree. So let's just ignore that and go ahead with our formula. So based on this equation, D equal to 100 into stadia intercept plus 0.1. What will be our PQ and what will be our QR? PR. Can you guys calculate and tell me? You don't even need calculator for this thing. What will be our PQ and what will be our PR? Okay, so let's not wait for this simple thing. We have some more interesting things, so I will solve them. So for PQ, we have intercept 0.32 when multiplied by 132 and then addition of 0.132.1 meters. And for PR, we have 0.21, so 21.1 meters. Right? Clear till here? And to identify QR, so now it's just a simple triangle formula, trigonometry formula, that if you know two sides and the angle between them, then what is the length of the other side? So I think we all should remember this formula, that if this is a triangle AB and this is the angle C, then the formula for this opposite side C will be A square plus B square plus 2 plus or minus 2AB cos theta. Okay, now tell me whether this is plus or minus. Who can tell me this? This is pretty simple concept, guys. Should be able to tell me this. Okay, no issues. I'll keep it a question mark, and I'll also tell if you forget in the exam. Let's see what we get from the how we can guess. Okay, someone is here. Okay. So I am getting a suspicious user request. So I'm going to deny that person to join here, and I'm going to admit only legit persons. Yeah, okay, so this is a new feature in some feature in Google Meet. Okay, yeah. So let's start to calculate the distance. So we have A. Let's take A as 32.1 square plus 21.1 square, and then question mark for you guys, and then 2 into 32.1 into 21.1 into cos of 61.5. So what is the cos of 61.5 degree? Okay. Does anyone want to volunteer? What is the cos of 61.5 degree? Muir wants to say something. I'm not able to hear you, Muir. Oh, wait a minute. I'm not sure. Oh my God. Okay. Yeah. Can you say now? Okay. Good. Yeah. We can even round off from cos 61 to cos 60 and get 0.5. That's a very nice thing. Let's see how. Uh, Minus will be the best suitable. Okay, let's take the minus and see what we get. So what is the answer we get from minus? Okay. Can anyone calculate and tell? 34 square. Okay, 28.25 meters. Correct. So minus is correct. And with this approximation of 61.5 to 60 degree of 0.5, we are only a little bit away from the answer. So maybe if this was a MCQ question, you can have a gander at this thing by taking it as zero point 0.5. Otherwise, the actual answer would be, I just calculated 28.8 meters. So if it goes out of your net values, no, can be a little bit problematic, right? So, but yeah, but that's a good suggestion that we can take 61.5 to 61 degrees. Oh, sorry, 60 degrees. Okay, does anyone have any question in this? And a nice way Muir has told us to, if we even forget the formula, we can, try to remember using this approach. Okay, if there are no questions in this one, we'll go to the next question. 2017 set 2 question number 38. So now we are starting our photogrammetry journey. Just I switched on my fan, it's getting too hot. Okay, so the question is, two towers A and B standing vertically on a horizontal ground appear on a vertical aerial photograph as shown in the figure. So you must be familiar that when we look at the satellite photos, the buildings don't look, we just don't see the top of buildings. We see the side of the buildings also. So that happens because, when this is a building, this is a tower, let's say, and this is a photo, this is a camera which takes the photo. It takes both the photos, right? If it is taking the photo from the top, you will get only the top, but we cannot do that for all the points on the Earth's surface. So when we take a photo, let's say this big photo, so only this one will be perfectly vertical. All these other things, we will be able to see their sides also. That's why the photos look like this. So what it is saying is, the photo looks in the photograph, this is the bottom, this is the top, this is the bottom, this is the top for two towers. The length of the image of tower A on the photo is 1.5 centimeter. So this is 1.5 centimeter, and for tower B it is 2 centimeter. The distance of the top of the tower A, as shown in this thing, is 4 centimeters from the principal point, and that for the tower B is 6 centimeters. So from this point, this A distance and B distance is 4 centimeter and 6 centimeter respectively. Okay, so if the height of the tower B is 80 meter, what is the height of the tower? Okay, so there are simple concepts to do this. One thing to note, that they have given horizontal ground. That means the bottom of tower A and the bottom of tower B, they are both on the same level. Right, so we don't have to worry about identifying that. What is the elevation for these two? Okay, so there are direct formulas to do this. So if you guys remember, the difference in the position of the bottom of the tower and the top of the tower in a photograph, what is the nice term for this? Can anyone tell me what is the nice term we use? Sorry? Relative displacement, yes, and one more term is there called relief, right? Oh, no, no issues, no issues. We don't need to remember all this terminology jargon, but just to freshen the mind. Relative displacement also we can say, and relief also we can say. So let's derive the formula for some of these things and then use them so that we can better remember when we are in the exam. Okay, so this is, let's say, this is our datum, average datum, and this is the bottom of our tower. This is our tower. So this is the bottom. The bottom it is at a height HB, and the top is at the height HA from our datum. This is our, and this is our plane, which is flying at a height of H, sorry, H from the datum. So how does the photograph works? So photo is nothing but you take the rays coming from the one portion of the every portion of the object, and then you trace it on a paper. And since there is a lens, so there is a lens that we use for taking the photo. Usually these photos are actually depend on the where we are focusing. So this focal length comes into picture. So let's say you have parallel rays coming out. Sorry, you have parallel rays coming from here, and then they meet. They will be converged to this focal length, and we have the photograph somewhere here. So photo plane will be at focal distance away from this plane, and it will be like this. So the photo is cast here. So this is your photo plane. So the top of your tower is going to appear here. This is your principal. See, this is perfectly vertical above the object, right? So this is called as principal point on the photo. So the top of the tower is going to be at r1 distance from your principal point, and the bottom of the tower is going to be at r distance from the principal point. And this r1 minus r only is the relief, or whatever is the length of the tower that is given to us. Okay, so let's get the formula for this r1 minus r. Just remember that this is our f, this whole thing is our h, this is ha from the datum, and hb. So let's put some points here. This is a, b, c, d. These are the points, and this is e, f, g. And one more point we need here, and we have already used h, so let me use here I. This is the point. Now if you look at the triangle ABC, which is similar to triangle AEF, are you able to identify this triangle ABC and AEF? So these triangles are similar because they have this angle 90-degree, and this angle is same, so the triangle will be similar. So when they are similar, we can say that BC divided by AB is equal to EF divided by AE. Let's put in the values. So BC is nothing but R divided by AB is the focal length. EF is the distance from the perfectly perpendicular drop from the plane to the bottom of the tower. Let's just call it L. This is not very significant. And AE, so yeah, AE is nothing but H minus HB, the height of the plane minus the height of the bottom of the tower from the datum. So this is for R. Now if you do the similar thing for the top of the tower, we have triangle ABD similar to triangle AIG. You will get R1 by F is equal to L by H minus HA. So is that clear? So I'm not allowing some people because this Google Meet is warning me that some email IDs are suspicious. So if they are your friend and they are letting you know that they are not able to join because of some reason, because they are not allowed, you can let me know, because I don't want any disturbance, any kind of stupidity in the class. Okay, so this is clear till here. R and R1 and R, just from similarity. So this relief that let's just call the commonly called as D, that is R1 minus R, will be L H minus HA minus L H minus HB. We take L common, and we do some kind of arithmetics, and you'll get to see that on the top you have HA minus HB. What is actually HA minus HB? HA minus HB is nothing but the height of the tower, the actual height of the tower. So let's replace this by that. So D is equal to LH by H minus HA and H minus HB. Now look at this. So I think I'm forgetting F here. Yeah, sorry. So F also will be transferred here. So R1 minus R2 will have F. So the relief is given by LHF divided by H minus HA and H minus HB. Right? So if you look at this formula here right now, this formula, LF by H minus HA is given as R1. Isn't it correct? So we can either write the relief as R1 H by H minus HA, or we can write it as R H by H minus HB. I'm not sure why so many suspicious mails are coming. I'm going to deny them still. So is it clear till here? Is everyone able to understand this correctly? Okay, I'm going to assume that you are understanding this, and we'll proceed. So after this, we just use this formula. This is the formula that actually is used in the question. So we'll use this. So what is given to us? Let's just write from what we have, what derivation we have done. The things that are given to us in the symbols that we have seen, let's write that. So the length of the tower in the image for the tower A is 1.5 and for tower B it is 2. So DA, that is the relief of A, is 1.5 centimeter, and DB for the second tower it is 2 centimeter. Okay, and what is the distance of the top of the tower A from the principal point is 4 centimeter. So R1 for A is 4 centimeter, and R1 for B is 6 centimeter. And we have the height of the tower B is 80 meters. So HB is 80 meters. So if you look at this, and we are asked HA. So if you look at this thing, for the tower B, we have 1 minute. Okay, so we have DB is equal to HB R1B divided by H minus H bottom of B. Now, since you have to remember that we have been given a horizontal ground, that means the H bottom of B is same as H bottom of A. That is correct. So using this formula, we can actually get this denominator, which will be same for the tower A also. Right? So let's get that. 2 centimeter is equal to 80 meter into 6 centimeter divided by H minus HB. So H minus HB is equal to 240 meter. That is clear. Now we know that. Now let's write the formula for relief for tower A. TA is equal to HA R1A divided by H minus HB. As I said, height of the bottom for A and B will be same because they are on the horizontal ground. So we have 1.5 centimeter is equal to HA in meters into R1A, that is 4 centimeter, divided by 240, that is in meters. So centimeter will get cancelled, and we have HA as 240 into 4 divided by 1.5. So HA as 240 into 4, sorry, 240 into 1.5 divided by 4 meters. So what's the answer here? 90 meters. Everyone understand this? Okay. Is any okay? So I am assuming that you understand. And if there is any mistake that I have done, you can let me know that of that also. Okay, we'll go to the next question. Okay, so now we are starting our some sub questions which will help us understand clearly the photogrammetry concepts. So the question is, the standard time meridian in India is 82 degrees 30 minutes east. If the standard time at any instant is 20 hours 10 minutes, the local mean time of a place for the place at a longitude of 20 degree east would be. So do you guys know? I think you will be knowing, just I am asking for my clarity, that the time on India now is different than the time in some other place, like let's say America. That is because of the Earth's rotation. And what we have done is we have divided our Earth into longitudes, some vertical lines that actually, this is like, let's say, 1 degree. Like this, we have divided our Earth, and there are time zones. So this will be one time zone, and this will be some other time zone, like that. I think you should be familiar with this, right? So what they have told us is that, let's say, if this is some 0 degree, if this place is some 0 degree, and we are moving east, and India is somewhere here, which is 82 degree 30 minute east, right? And the time here is 20 hours, so let's say 8 p.m and 10 minutes. So what will be the time on some place which is here, which is actually 20 degree east? So if we were able to calculate the time difference between these two longitudes, then we will be able to tell what is the time here, right? Now, who can tell me how many degrees equal to 1 hour? How many degree difference in the longitude equals to 1 hour time difference between the two locations? Because that is what basically, if you know that, you can answer this question. 15 degree. Silent Harry, yeah, very good. 15 degree. So, what is the total difference in degrees between these two? Delta. It is 62 degree 30 minutes and 62.5, we can say precisely, degrees, right? Now let's divide it by our 15 degree, and we'll get the difference in the time in hours. So 62.5 divided by 15. How much is that in hours? It is 4.16 hours. Basically 4 hours and 10 minutes. So the time difference, now here's the thing, what they have done, they have also given 4 hour 10 minutes. So we should not just immediately go and tick that answer. This is the time difference between the two longitudes. So we have to subtract this from our 8 p.m. 8 p.m. 10 minutes, this 4 hour 10 minutes, and then we'll get the answer, that is 4 hour p.m. So answer is A. And also one more thing you should know, that when we go towards so the sun rises in the east, that means it sets also first in the east. So if we are asked some time on the more towards this direction, we have to subtract the difference from this time. We cannot add. Also, is there any question why we are adding or subtracting? Okay, cool. We'll go to the next question. An image of the top of a hill is 96 mm from the principal point of a photograph. So let's side by side, let's write from the derivation that we did the notations for this formula. So the image of the top of the hill is 96 mm from the principal point. So R1 is given 96. The elevation of the top of the hill is 500 mm. So elevation of the top of the hill. So HA we have 500 meters. And the flying height is 400 meters. So our flying height is 400 meters above the datum. Okay, so they have given that this is above the datum. So the relief displacement will be, so what have we been given? This is the datum. Let's say this is the datum and our tower goes to the bottom of the datum. This is our HA, that is 500, and this is our H, this is 4000, and this R1, okay, this R1 is 96 mm. So what is asked? What is the relief displacement? So that means if we were to draw something like this, if we were to identify the location of the bottom from the principal point, then what is the difference between these two things, or the height of the tower in the photograph? That is asked of us. So here is the little bit tricky part. We see, if look at this carefully. You can, if you remember this formula for your relief that we derived earlier, it was R1H divided by this H minus HB, right? Now we don't know anything about the bottom. For all we care, this datum can go to the bottom of the tower. Because, previously when we derived, we assumed datum should be here, and then we took HB and then HA. Since in this question we are not given any information about the bottom, we might as well say that the bottom, or the bottom of the tower, is my datum. So when we do that, this H minus HB, HB becomes 0 first of all. H minus HB becomes, where is that? Yeah, H minus HB becomes H, the flying height, and our H, this top of the thing, the top elevation of the top of the hill, that H becomes HA. So it becomes 500. So if we use this shortcut, if we use this some kind of trick, then we can easily get the answer. 96 mm into 500 divided by 4000. So what is the answer here? Okay, so the answer is 12 mm. Is there any doubt why we did this assumption? We can go by that long approach also, or we can use similarity triangle and get, you know uh, try to use some other way. But this is also one of the shortcut ways we can do, because they have not told us the datum. I am free to assume that my datum is the bottom of my tower. Okay, if there is no doubt, we'll go to the next question. Okay, so this is a good question. A tower appears in two successive photographs taken at an altitude of 4,000 meters above the datum. The focal length of the camera is 160 mm. The length of the airbase is 300 meters. The parallax of the top and the bottom of the pole are, so okay, 72 mm and 63 mm respectively. Then, the height of the top of the tower above its bottom is nearly how much? So how many of you are familiar with the, parallax concept when we talk about photogrammetry? Okay, no need to answer that question. I'll just say what is actually this parallax. So let's say you have a tower and you have your plane here. This is the focal, which the plane is going on a, same height, same flying height, same cruising height, and it traveled some distance b, and it took the photo of this tower from both these locations. So this photo plane that will be at the focal length distance from the aeroplane, here the photo will look like this. So this is the first photo. Let's say this photo is from here to here, and this plane, sorry, this top is coming here, this bottom is coming here on the photo. So let's say now the photo is from here to here. This is the photo, and this is the principal point. Same way, we have taken a photo from this side of the tower, and the tower will appear something like this on the photo, right? The top of the tower will be here, the bottom of the tower will be here. Now if you look at these photos in this plane, and just for simplicity we'll be going to assume this 1D only, that the tower was on this line only. We are going to assume that. So if you look at this photo, this is your principal point. This was the bottom of your tower, this was the top of your tower, right? Bottom, top. This is the principal point. When you look at this photo, then this was the top and this was the bottom, correct? So the distance your top of the tower and the bottom of the tower has moved, in your focal plane, when you have taken the two photos at some distance, that distance traveled is actually called the parallax. So let me integrate these things, these two photos. So principal point, even though the vertical location is different, but the principal point of the photo, if we, let's say, keep it as O, previously the top of the tower was here and later on it came here in the photograph. So the sum of these distance is the parallax. Similarly, for bottom, B, sorry, B and B dash. This is the parallax for bottom. Now from this figure, if I was to ask you this question, that the top of the tower or the bottom of the tower, which portion of the tower seems to be moving faster, then what will be your answer? Come on guys, this is a very basic question. It took some time t for this thing to travel from there to here, this aeroplane. In that time, the bottom of the tower has traveled from here to here, whereas the top of the tower has traveled from here to here in the photograph. So which one appears to be moving faster? Definitely the top of the tower, right? And that is the answer for the question that I asked. Like which one appears to be moving faster? The bottom or the top? So the answer is the top. Okay, now I've told what is the what is the uh, parallax. It is the sum of the distance from the principal point in the two photographs. So let's just try to write the formula for that. So from our derivation earlier, you might be able to remember that since they have given specifically some information about the bottom also, I am not going to assume that the bottom is the datum. I'm going to assume that bottom is something which with height hb from the datum, and top is something with height ha from the datum. And I will just write in from one side, and we'll say from similarity or something for the other side. So let's say this is at a distance xa for the first photograph, and since this is the air base is b, this will be b minus xa, right? So if this is the focal plane and this is the photograph, I can write this as r1 for the top. So this is the height of light, which is same for both, and this is our another triangle. So if I was to write this relief r1 by making using the similarity in this triangle and in this triangle, I will get r1 by f. So this is f, the focal plane, is equal to xa by h minus ha, right? So r1 is nothing but f xa by h minus ha. Now if you look at this carefully, ha doesn't change, h doesn't change. The only thing that will change if I want to get this r1 dash is this distance, like the vertical distance from the vertical drop from the plane. So I can write r1 dash as b minus xa, f, focal length of the mirror doesn't change, and h minus ha, right? You can write this. And what I said, what is the parallax? It is the sum, it is the total distance traveled by the object on the image. So it will be r1 plus r1 dash. So the parallax for the top will be fxa by h minus ha plus b minus xa f by h minus ha. If you add, this will be b f h minus ha. This is the formula for parallax. So we have been given the parallax for the top and parallax for the bottom. So similarly, if you do the same thing, no, we have already written the formula for r1. We have written, so for r it will be nothing but xa f divided by h minus hb, right? So the parallax for r, I'm just going to write it here. I'm going to erase these things, and I'm just going to write the parallax formula now. Let me erase these things here. Okay. So parallax for the top was b into focal length divided by h minus h a. Parallax for the bottom will be b into focal length divided by h minus h b. Right? Simple formula. So now that we know these things, let's see what the question is asking. So the question is asking that I have given you this focal length, I have given you the height of light, I have given you the base, air base, that is this b, I given you the parallax also. Now tell me the height of the top of the tower above its bottom. So it's basically asking us HA minus HB. So we can identify that using the values. We can identify HA from this equation, HB from this equation, HA minus HB we can easily get. So let's do that. 72 for the top is equal to 300, the airbase meters, into the focal length, that is 160 mm. So the mm will get cancelled here. And h, that is 4000 meters minus HA. So if you solve this, what is the value of HA you are getting? Can anyone solve and tell me? I will also solve, but if you can do quickly, we can save some time. So we have HA 3033.33 meters. Please let me know if you are getting something else. And similarly, HB will be 63 equal to 300 into 160, current remains same, 4000 minus HB. So what is this? 3238.09 meters. So what is our delta H? Delta H is nothing but HA minus HB, that is 95.23 meters. So the answer is C. Is that clear for everyone? Okay. So one more thing that can be asked using this parallax concept is what they will do is they will actually give you the difference in the parallax between the top and the bottom. So delta P they can give, right? And they can ask you what is the delta H. So I think it will be beneficial if you know this formula also. So let me just derive this. So B and focal length F will come common outside. And when we simplify this, we have HA minus HB upon H minus HA, H minus HB. That is the difference between the focal length. So, and if you just look at this, this is nothing but the parallax for the top. So parallax for the top into delta H by H minus HB, or parallax for the bottom into delta H divided by H minus HA. You can remember these formulas to apply directly if you have been given the difference in the parallax for the top and bottom. Okay. Is there any doubt in this parallax question? Okay, good. So we'll go to our last question for the day. That is vertical photo. It's also a simple question. So I'll read the question and I will encourage you guys to attempt this question and tell me the answer. It is just simple question, not it doesn't even have parallax. A vertical photograph of a chimney was taken from an elevation. Little bit late, but someone wants to join, so we'll add them. A vertical photograph of a chimney was taken from an elevation itna above mean sea level. So if this is our datum, this is the plane, this is 500 meters. From here we took a photograph of a chimney. The chimney, the elevation of the base of the chimney was 250. So chimney was somewhere here and the elevation for that was 250 meters. If the relief displacement of the top of the chimney was this much and the radial distance of the image of the top of the chimney was this much, the height of the chimney is. So what are we given? We are given the relief displacement, that is D, 51.4. So if you remember from our formula, R1 minus R is given to us. And also they have given the radial distance of the image from the top of the radial distance of the image of the top of the chimney. So when they say radial distance, that means they are talking about the distance from the principal point. So they are talking about this distance. That is nothing but R1. So R1 they have given 110 mm. H they have given 500. HB they have given 250 meters, and H is 500 meters. Now can you guys tell me H, that is the height of the chimney? It is just a simple formula based question. And since this is the last question, I am going to wait for someone who can tell me the answer. Simple question, guys. Okay. So I don't like the silence. Is anyone solving, or I'm just silently waiting for no one to answer? Okay. So I think I have waited enough. I will write one formula. We'll use this. We'll solve this using this formula. D, the relief displacement, is nothing but H into R1. Okay, very good. Pallavi has solved. Thank you, Pallavi. So Pallavi has solved and she has got the right answer. So the formula for relief displacement is H R1 by H, the cruising height, minus HB. And when you look at this, it is a very straightforward question. And you solve this, you get meters. Okay, so yeah, so that's all for today. That's all for photogrammetry. So is there any doubt in the topic we have discussed so far today? We have discussed photogrammetry mostly. So okay, someone's that's the answer. Okay. Okay, guys. Then thanks for joining in, and have a nice week. We'll meet again on weekend.